My name is Ofubi Wallace NMD, and I'll be doing my presentation in an autonomous wireless sensor network deployment system using mobile robots for human existence detection in case of disasters. These are the contributors for the paper, and they were all from Turkey, although from different universities, but had the field in computer engineering and programming. As a way of introduction, mobile robots are used to help with specific tasks. These tasks, such as planetary exploration, reconnaissance, and in some cases rescue missions, are many often time dangerous, and thus makes it wiser to send robots rather than to send humans. Robotic exploration has piqued the attention of various researchers over the years and thus having made them use of various strategies for exploration. This includes the frontier-based strategy, the market-driven exploration strategy, and the role-based strategies. But I will actually buttress more on the role-based strategy because that's what they actually used in the paper. As the name implies, are specific to their roles. It is an exploration algorithm for multiple robot systems that aim to efficiently gather information gotten from all members of the team in a single location. Some robots in the team are in this case meant to explore the environment, while others are relays referring information back and forth between the team. Role-based exploration demonstrates several advantages over other methods, particularly when communication becomes less reliable. Having talked about the various strategy briefly, I would like to chip in to say that the goals for mobile robot exploration are simply to gather information when in target region and to ensure that the target region is completely covered. Before we go further, I would like to state that the main requirement for all exploration strategies is coordination of multiple robots to improve efficiency. SLAM is simply an acronym for simultaneous localization and mapping, and is the process of building a map of an unknown environment with from a sequence of noisy landmark measurements gotten from sensors. Saying that mapping is a critical part during multiple robot exploration, the cooperation of multiple robots allows mapping an unknown environment more quickly and robustly rather than when you use a single robot. WSN is the main topic for this paper. It involves the use of multi-aided wireless sensor network deployment system. In this system, a group of mobile robots are used to explore an unknown region and cooperatively perform SLAM. In addition to this, during the exploration, sensor nodes are deployed to help detect any form of human existence and provide communication between the robot and the control center. WSN allows increasing communication range and covering a larger region. Sensor nodes used in this paper is passive infrared sensor as motion detectors to detect human existence. If an object detected signal is sent by the PRS sensor, the nearest robot is directed to that area to take picture of it in order to make sure that the object detected is human, and then this photo is then sent over the WSN to the control center for identification. If a human is detected, then an equipped rescue team will be sent. It is important to note that it occurs after a disaster and brings cost advantages compared to pre-deployment strategies. The WSN also serves as a communication platform between robots and the control center. I think I've already stated that. For related works, Avatar, an autonomous helicopter designed for sensor deployment and repair. In this work, a proposed algorithm was implemented using a sensor network with 50 nodes and Avatar as the autonomous robot. The executed task was done on a 7x7 grid in both manual mode and autonomous mode, and we were able to compare the results. The shortcoming here was that the deployment error within 1 to 3 meters, and they actually had some nodes that actually remained disconnected. Marvin is a sensor node deployment device under a project called AWARE. The AWARE project aims in enabling the cooperation of autonomous unmanned aerial vehicle with ground wireless sensor. During the deployment test, it was noticed that the communication problems appeared in some nodes due to the position of the antennas on the ground. Design consideration for this paper included the battery life for the wireless sensor, the detection range for the PRS sensor, which was about 6.1 to 9.1 meter, the communication range and the performance of the wireless sensor, mobile robotic exploration strategy, as in this case role-based strategy, the robotic arm known as the gripper that had 4 degrees of freedom, the exteroceptive sensors such as laser rangefinders and the ultrasonic rangefinders to perform cooperative SLAM, and cameras that had pan, tilt, and zoom capabilities to take pictures. And this is what the robot looks like. The robot shows the side view and the front view of the four-wheel drive robot that was designed for this study. The robot runs on Ubuntu, and as we've used ROS in our labs, ROS provides device drivers, hardware abstraction layers, libraries, and tools to help developers create robotic application. For the advantages for WSN, it helps with the collection of data from physical world through the sensor nodes and is transmitted through a single or multiple hop communication. It can also propose a dynamic system in which the sensor nodes can be collected and deployed again using a rescue mission. In hazardous environments, the system has potential to use robotic exploration and SLAM application. In cases such as nuclear and chemical disasters, food and water can actually be delivered to the detected people by the robot. Also, not to forget that the rapid deployment and flexibility also aggregated intelligence via parallel processing. Motivation for this paper was actually from a nuclear disaster that occurred in Fukushima, Japan, and it actually helped the government and security forces measure the radiation levels affected in areas without compromising human life. Communication models for this paper included static cycle model, simply tells us when a robot X is within a communication radius of a robot Y. They tend to communicate regardless of any obstacle. The line of sight model that involves two robots communicating with each other when there are no obstacles and they are in a direct line of sight between them. The propagation model is actually a realistic model in which thickness of an obstacle is taken into account and communication range is calculated. WSN are generally characterized by many to one traffic pattern, so a common problem is energy imbalance among sensor nodes. That is, sensors closer to a sink are usually required to transit a large amount of traffic and their batteries tend to deplete earlier, in turn reducing the functional network lifetime. As a means of conclusion, I would like to state that paper focuses on an autonomous mobile robot to deploy a WSM for human existence detection and explain design challenges and methods in case of disasters, advantages over assisted systems such as autonomous deployment, flexibility, and aggregated intelligence. These are the references, and thank you for listening. I'm hoping for your questions.